While 88% of organizations have deployed AI, only 6% generate breakthrough value. 94% are burning cash on failed initiatives, and Gartner projects 60% of these will be permanently terminated by 2026. Grounding these numbers is the case of a major fintech CTO who invested $2 million in a state-of-the-art data warehouse, only to end up with a chatbot that hallucinates the names of the company's own products. Massive financial investment in data storage does not automatically translate to AI capability. This is the central paradox of the enterprise AI gold rush. The data-ready delusion is the false executive belief that possessing a well-organized data warehouse is the same thing as being ready for AI. It is like owning a massive well of crude oil. Without a refinery, industrial pipelines, and specialized storage, that raw resource is useless. One retail data engineer discovered this when his company's flawless Tableau-ready data warehouse failed completely the moment it was plugged into an AI system. Legacy data systems are optimized to display charts for humans. Artificial intelligence requires data formatted specifically for machine learning. The gold standard infrastructure of the business intelligence era was built for human reporting, not machine learning. Using it as an AI foundation generates the technical friction that leads to these systemic failures. Traditional business intelligence operates on a specific philosophy. Data must be perfectly clean, standardized, and stripped of all outliers to be valuable. Large language models require the opposite. They need messy, complex data to accurately reflect the chaotic reality of the present. If you erase the anomalies to create a clean chart, the AI loses its ability to learn how to handle real-world exceptions. Moving past the philosophy requires concrete engineering infrastructure to make data machine learnable. The first required layer of the stack is semantic chunking. Traditional processing blindly slices documents based on fixed character sizes, which often cuts sentences in half and destroys their meaning. Semantic chunking instead slices data along natural boundaries, like paragraphs or topic shifts, preserving the context the model needs to understand. The second layer is hybrid retrieval. Vector search is excellent for finding semantic meaning, but it frequently misses exact keyword matches, like product codes or IDs. Combining semantic vector search with traditional keyword search creates a comprehensive retrieval net that catches both the concept and the specific term. Without these two layers, an LLM is effectively trying to read torn, out-of-order pages from a disorganized dictionary. The third layer is active metadata. Unlike legacy metadata that just logs file dates, active metadata provides business context and trust signals directly to the AI model. The fourth and culminating layer is GraphRag. GraphRag structures isolated chunks into a mapped knowledge graph, giving the AI the ability to perform multi-hop reasoning. This architecture ensures the AI doesn't just retrieve a blind guess, it can mathematically trace and prove why its answer is correct. Even with this infrastructure, projects fail if they are deployed using standard software testing habits. Vibe coding is the amateur practice of writing a prompt, getting a plausible-sounding answer, and immediately shipping it to production. The results of this practice are catastrophic. Bots suggesting products discontinued years ago, or hallucinating pricing discounts weeks after launch. The antidote is evaluation-driven development, or EDD. First, engineers must manually audit 20 to 50 raw AI outputs to locate the system's exact breaking points. These errors are categorized into a failure taxonomy, a map of distinct failure modes used to guide the engineering process. Relying on human intuition to evaluate a probabilistic AI model guarantees failure. Rigorous error categorization is non-negotiable. In the Hussein framework, every AI output must survive 3 distinct security gates. Tier 1 consists of deterministic assertions. This is a hard logic unit test that automatically verifies the rigid structure and formatting of the output. Tier 2 is LLM as a judge, where a more powerful AI model scores the output against strict criteria set by domain experts. This tier removes human bias and allows for scalable, automated qualitative testing. Tier 3 is A/B testing. Only outputs that survive the first 2 tiers enter live environments to measure actual end-user response. Enforcing these 3 tiers is the only way to force deterministic reliability onto an inherently probabilistic system. AI value is found through a specific journey, from messy data through a 4-layer infrastructure and past 3 evaluation gates. Bolting an LLM directly onto a legacy business intelligence pipeline is structurally doomed to fail. Look at the operational difference. On the left, we have a dynamic, constantly adapting knowledge graph. On the right, a rigid, static data warehouse. Technical leadership must decide if they are prepared to abandon the comfortable dogmas of the business intelligence era. You must trade the obsession with perfectly clean data for the messy reality required for true AI reasoning. Clinging to the so-called data-ready delusion guarantees placement in the 94% of companies currently incinerating their capital. Surviving this entire transition requires trading the illusion of perfect business analytics for the harsh discipline of evaluation-driven engineering. Real AI value is not extracted passively from a dormant warehouse. It is actively engineered through relentless architectural and evaluative discipline.